I recorded this yesterday, but one of the students told me that he couldn't just play it, and it made him download it, which takes forever. So I guess it's because it's longer than the one from Tuesday. So what I'll do for anybody that does have to leave class early, um, I'll put I'll put instead of putting them on Google Classroom, because it seems like the big ones you can't just watch live, and a couple of you guys can't get into the Google Classroom. I'll post them on YouTube, on my teacher page on YouTube. So you can just go. You don't have to wait for anything to download. You can just watch the video if you had to leave class early. All right. So my apologies to anybody that was trying to watch it yesterday and had trouble. All right. Let's do number 40 and maybe one of the word problems. All right. This one here, I've got two vertical asymptotes. X equals -2, and x equals 3. These graphs aren't showing me any holes. So I definitely have to have x plus 2, x minus 3 on the bottom. Do I have a horizontal asymptote? Let's see if people are understanding what they're looking at.
No.
Got one no.
Yes. Yeah.
Yes. What is my horizontal asymptote?
It is x squared.
It's y equals 0. If you look at this graph, it's leveling off, getting closer and closer to the x-axis. If we didn't have a horizontal asymptote, we would have seen this graph shoot back up into towards infinity. All right, and on this side, it's also leveling off, getting closer and closer to the x-axis. So I do have a horizontal asymptote, and it's y equals 0. And when the horizontal asymptote is y equals 0, I know the bottom, the denominator, has the higher degree. All right, so right now the denominator has degree 2. So unless I'm going to add another factor on the bottom, the numerator can only have degree 1 or 0. All right, now I'm going to look for any other features of the graph that I might have missed, and here's one. I've got an x-intercept of 0. So that means x equals 0 has to make the numerator equal to 0. So it's also a y-intercept, right? My x-intercept and y-intercept are 0. It goes through the origin. But for the x-intercept to be 0, I need x minus 0 to be a factor of the numerator. All right, and if I just look at what I have right now, I've got everything. The denominator has the higher degree. So I've got my horizontal asymptote is the x-axis. I've got x plus 2 only on the bottom. I've got a vertical asymptote of x equals -2. I've got x minus 3 only on the bottom. I've got x as a factor of the numerator only, so it's a 0. And then when I plug in 0 for x, I get 0 over -6, which gives me a y-intercept of 0. So that is my solution for number 40. Questions on this one? Let's do one more for good luck. How about let's do number 42. Was somebody trying to ask me something?
Now I was going to say the 42.
Okay. You have I think you have a slow connection today, so I can hear your audio, but it's breaking up a lot. It's kind of going slow. So if you're able to put something in the chat, if you really need me to hear.
No, I was saying that I was going to say let's try number 42.
Oh, okay. Yeah, I can hear you this time. Thanks. So we're having the same thoughts. Great minds think alike, right? All right. So two vertical asymptotes, x equals -2 and x equals +3. That means I've got to see x plus 2 and x minus 3 on the denominator. I've got a horizontal asymptote of y equals 0. So the bottom has the higher degree. All right. So as far as all that stuff goes, I could just put a 1 on top and I'd accomplish everything. But I wouldn't have this. The graph of g crosses the x-axis once. And it looks like it's about to say where. Did it say where and I missed it, or was it not there? It might be on the next page. So if it said at x equals 5, I'd put x minus 5 on top. But the way, as far as what I copied, it doesn't say. G crosses the x-axis once. Well, I don't want to say it crosses at -2, because if I put x plus 2 on top, I'd have a hole at x equals -2, and I wouldn't have really an x-intercept or a vertical asymptote there. And I can't say +3, but I can pick any other number I want. So why don't I stick with that x minus 5? So mine has an x-intercept of 5. And now I've taken care of everything. When I go back and check, I got this. I got this. I've got this because the bottom has degree 2 and the top has degree 1. I've got this. Mine crosses the x-axis at +5. All right. And if I wanted to get fancy with it, I could put a -2 in front, but there's no need to do anything like that. We've gotten everything done that we want to get done. Look okay?
Yep.
All right. Any other miscellaneous questions on the homework? By the way, the second section of homework is something I meant to get to yesterday, and I didn't, and I forgot to take it off the homework. So if you were a little confused on the second section, that's my fault, not your fault. But we're going to take care of those kind of problems today.
That was question 15, right?
Yes. Okay. Yes.
Okay.
Oh, actually, was 15 the one that said cosine of alpha equals 3/5? Let me see. Brian asked me something. Let me see if I can find his message here. No, that was 26. Okay, yep.
Can we work on 15? Because
Elizabeth, could you just tell me what problem says in number 15?
Okay, sine t equals -1.
Yeah, so, yeah, this is the section that I meant to cover yesterday and I didn't. But let's start with number 15. Remember that sine of an angle is the y coordinate of theta's terminal side on the unit circle. All right, and if you think about the unit circle, there's only one place where y equals -1, and it's at the very bottom of the unit circle. All right, the unit circle has y values, everything between +1 and -1 including, and the highest x value it has is +1, and the lowest x value it has is -1. So there's really only one place on the unit circle where y equals -1, and it's at the bottom. All right, and I believe it said to give all solutions between 0 and 2 pi. So that means this angle t is 3 pi over 2. If we were in degrees, we'd say 270 degrees. All right, so yeah, don't feel bad about missing that section. We didn't address it in class, but that's what we're going to focus on today. All right.
Thank you.
Does anybody have a preference? You want to start with trig or you want to start with rational functions?
Trig.
Trig? All right, let's do it. Okay. So let's see. Okay, let me okay. Board. Let me see if I can okay. Okay. Keep this chart on the board too, if possible. How can I do this? Boy, let's see. You know, okay, you guys are gonna have to bear with me for a second. Let's start off with some problems in degrees. We're going to give all solutions between 0 degrees and 360 degrees. And you're going to need to have that chart. We're just going to focus on sine, cosine, and tangent today. So I'm having trouble getting just one picture put in here, but we've got 30, 45, 60, sine, cosine, tangent. This is terrible. My software is acting up a little bit here. All right. Do you guys have those charts handy? That would make life a lot easier.
Yeah, I have it.
Okay, beautiful. All right. So I want to solve a trig equation. Theta represents an angle, and I want to give all possible solutions between 0 and 360 degrees. So in degrees, what angle has a sine value of square root of 3 over 2? Is it 30, 45, or 60?
30.
It's not 30. Cosine of 30 is root 3 over 2.
60.
60 degrees. All right, so I want 60 degrees as my reference angle, but I also need to make sure sine has a negative value. So, oh geez, software's, oh my God, software is acting up today. Now I'm erasing. This is frustrating. Okay. Pretend that's a line, please. All students take calculus. All right. So which two quadrants can sine have a negative value in?
Tan and cos. Yeah.
Right. You're looking at the right two quadrants in 3 and 4. They're all positive in quadrant 1, so I can't give an answer in quadrant 1. everything in quadrant 2 has a sign that's positive. I've got to be in quadrant 3 or 4. All right, so I'm going to make a little sketch for myself. I want to be 60 degrees below the x-axis in quadrant 3 or 60 degrees below the x-axis in quadrant 4. Can anybody tell me how many degrees is this third quadrant solution?
240.
Good, it's 240. And the reason is this is 180 and I'm 60 degrees beyond 180. So 240 degrees is one solution. And what's the fourth quadrant solution?
300.
Yeah. If I was allowed to give a negative answer, I could say negative 60, but the instructions say I'm looking for solutions between 0 and 360. Here's 360. This angle is before I get to 360, so that makes it 300 degrees. So those are my two solutions for theta. Theta could be 240 degrees or 300 degrees. Okay to move on to number 2? And that means if you have a question on number 1, please speak up. All right, let's move on then. What's my reference angle for number 2? Which angle has a tangent value of square root of 3? 30, 45, or 60? Yep.
60.
Good, 60 degrees again. But now I've got a positive value for tangent. Which two quadrants can tangent have a positive value in?
You mean have a negative? Wait, a positive.
Positive, because look, this says tangent of theta
3
is positive square root of 3.
First and the third.
What?
Good. The first
And the third.
and the third. Perfect. All right, so I'm going to make a little sketch for myself. I could be 60 degrees above the x-axis in quadrant 1 or 60 degrees below the x-axis in quadrant 3. What's my first quadrant answer?
So 40.
60.
Yeah, just 60. Because think about it. This is 0. I've moved up 60 degrees. So 60 degrees is one solution. And what's my third quadrant answer?
240.
240 degrees. Good. So 240 degrees and 60 degrees. Those are my solutions.
Is this what when you hit second sign on your calculator, is this what this is?
Okay, good question, Mark. So if yes and no, yes is the main answer. If you asked your calculator, if you were in degree mode, first of all, you put your mode in degrees, and you asked for the inverse sine of negative root 3 over 2, it would give you negative 60 degrees. Your calculator will always give you the fourth quadrant answer for a negative sine value. So it would give you negative 60 degrees, and you would have to use your knowledge of the unit circle to figure out the 240 degrees. Okay? These are all values we're expected to be able to do without a calculator. But if I asked you, and we'll do this on a little bit on Monday, what sine of theta equals 0.2457, nobody I know has that memorized. That's where we ask the calculator, what's the inverse sine of 0.2457? And then we use the calculator's answer to figure out the secondary answer. Okay.
Right, thank you.
Pleasure. Yeah. Good question. So let's move down to number 5. Let me pick on some people here. Alani, are you here today?
Yes.
All right. Well, so what's my reference angle if cosine has a value of positive or negative root 3 over 2? What's my reference angle? Is it 30, 45, or 60?
It said 30.
Good.
And if it's not 30, yeah.
Yeah, no, it is 30. Yep. And what 2 quadrants can cosine have a negative value in, Nina?
Quadrant 2 or 3.
Good. Quadrants 2 or 3. We can't give a first quadrant answer because we're in the A. All of them are positive. We can't give a fourth quadrant answer because we're looking at the C. Cosine is positive. We have to be in quadrant 2 or 3. So I'm going to make a little sketch for myself. And the reference angle is always the distance to the x-axis. So you always want to put your 30 degrees or whatever the angle is between your angle and the x-axis. Here's 180. So Nicoletta, what's my second quadrant answer?
The second quadrant answer?
Yeah.
What the?
This one right here. How many degrees did I come from 0 if I stopped here?
120.
You're warm, but I stopped 30 degrees before I got to 180.
Oh, so 150.
Right, 150. All right, and then my second answer is 30 degrees after 180. So how many degrees is that? What's this one down here?
Is anyone allowed to answer?
Oh yeah, so I guess I was looking for Nicoletta to see if she could get that one, but I didn't.
Sorry.
I didn't make it clear, did I?
It's 210.
210. Good, thank you. All right. All right, let's do one more of these and then see if you guys can get some of these on your own. How about number 6? Cameron, are you here this morning? All right, Chiruza, what's my reference angle on this one? What angle has a tangent value of root 3 over 3?
Yeah.
30, 45, or 60?
We have 60. Oh, no, it's 30.
Good, yeah. It is 30. So it's a 30-degree reference angle again, just like number 5. But now I'm looking at it and I have a negative value for tangent. So what 2 quadrants could I possibly be in?
The second and the fourth.
Good, the second and the fourth. I'm going to try this again. Okay, not bad. So anyways, for anybody that needs this, this is 1 over 2, 2 over 2, 3 over 2, 3, 2, 1, root 3 over 3, 1, and root 3. So yes, we're in quadrant 2 or 4, and draw that out. I could be 30 degrees away from the x-axis in quadrant 2, or I could be 30 degrees away from the x-axis in quadrant 4. Can you give me the quadrant 2 answer?
150.
150, good. 30 degrees before 180. If I'm on the left side, I'm always thinking based on 180 degrees. And let me just make that a little bit easier to read. And Diana, how about the fourth quadrant answer?
330.
Good, 330. All right, again, sometimes you can just say negative 30 degrees. In fact, your calculator will tell you negative 30 degrees. But if the instructions say give an answer between 0 and 360, in the fourth quadrant, you want to go by 360. In the first quadrant, your reference angle is your angle.
I have a question.
Yes.
Let us go back on number 1,
Sure.
where you say negative 3 over 2. But to the table, root 3 divided by 2 is sine 60 and also cos 30. So which one do we use?
Yeah. So that's an important question. But this is sine, right? This is sine of an angle. So I have to look for root 3 over 2 in the sine row. So I'm looking at here. Do you see that? If it said cosine of theta is negative root 3 over 2, then yes, I would be looking at 30 degrees. But because it's sine of theta is negative root 3 over 2, I'm looking at the values for sine. You understand that okay?
Yes, sir.
Good. All right. How about, why don't we have you guys take a few minutes and try these 4 on the right-hand side. Oh, jeez. You're multi-talented. Extra credit for songs.
I have to go to the class now.
All right, good luck. I'll try to make it easier for you to watch the video today.
All right, thank you.
All right.
Have a good day.
You too. Thank you. Attendance here. Please speak up if you have any questions.
Oh, Mister, can I say this number? Is it number 6?
You want to see number 6?
Yeah, I forgot to copy. Thank you.
Sure. I'm going to slide it over in a minute just so people can see the chart. I'll give you a second. And Thomas, I figured out why some of your emails were bouncing back. The list I got from Mr. Howland had one misspelling in your email. So I fixed it, and now you're getting all my emails. I'm going to move this back over. How many people would like a couple more minutes? All right, let's check in and see where we're at on these. Mata, can I pick on you for a minute? What's my reference angle on number 3? What angle has a cosine value of root 2 over 2?
45 degrees.
Good, 45. And now I've got a positive value. Which two quadrants can cosine have a positive value in?
1 and 3.
1, yes. But if you look at 3, that's got the t in it. That means...
Oh, I wrote 3, but I meant 4. Sorry.
Okay, good. Yep. So quadrant 1, quadrant 4. The C means cosine's positive. So I want to make a little sketch for myself. 45 degrees above the x-axis in quadrant 1, 45 degrees below the x-axis in quadrant 4. Do you have the final answers, Mata, on this one?
Yeah, for quadrant 1, it's 45 degrees, and quadrant 4, it's 315.
Perfect. Yep, quadrant 1, you just go from 0. I'm 45 degrees above 0. Quadrant 4, you go from 360. I'm 45 degrees before 360. Does anybody have questions on this one? All right. Jakina, how you feeling about these?
It's all right.
Okay.
It's not that hard.
Should I ask you a few questions, or you want me to move to somebody else?
You good? I'm still watching.
Okay. So what did you have a reference angle for number 4? What angle am I looking at? 30, 45, or 60?
For number 4,
Yeah.
that part I don't understand.
Okay. So let's.
It's right there. Okay, so it's negative 1.
Yep.
Isn't it 45?
Yes, exactly. You're looking in the tangent row. I'm looking for a 1. All right. We'll deal with the negative in a minute. So 45, and now I just have to figure out. Now I'm looking at the negative. Where can tangent be negative? So I'm looking at A. They're all positive. Not quadrant 2. I mean, not quadrant 1. Now I'm looking at the S. The S means only sine is positive. So that means, well, tangent must be negative. So I'm going to include quadrant 2. Now I'm looking at the T. That means tangent is positive. Only tangent's positive. Well, I need tangent to be negative. So it's not quadrant 3. It's got to be quadrant 4 is my other quadrant. The C means only cosine is positive. So therefore, tangent must be negative. Sound all right?
Yeah.
All right. So, and then make sure the 45 degrees when you draw your sketch touches the x-axis. And then on the left side, you're going by 180. Am I before 180 or after 180 if I'm in quadrant 2?
After?
Well, don't forget, here's 0, and positive angles go this way.
Oh, before.
That's right. So I'm before 180. So it's going to be 180 minus 45. 135 degrees is going to be my first answer.
Okay.
Okay. And then the second answer is almost all the way around the circle. It's before I get to 360. So 360 minus 45, 315 degrees. All right. Let's see here. What was that called on? Elizabeth, what'd you get for a reference angle on number 7? Number 7. The cosine of theta is 1/2.
60.
Good. 60 degrees. And I've got a positive value for cosine. So, yep, 1 or
4.
good, 4. So 60 degrees above the x-axis here, 60 degrees below the x-axis here. In quadrant 1, everything's positive. Quadrant 4, because the C is telling me cosine's positive. So what's my quadrant 1 answer?
60.
60. And what's my quadrant 4 answer?
300.
Good, 300 degrees. All right, and again, the quadrant 1, I'm just going from 0. I'm 60 degrees after 0, so that's 60 degrees. The quadrant 4 answer, I'm basing it on 360 degrees. I haven't quite gone 360. I've gone 60 degrees short of 360, so that's where the 300 degrees comes in. All right. Chelsea, what'd you get for a reference angle on number 8?
Number 8, I got 60 degrees.
Good, 60 degrees. And what two quadrants can we have a negative value for tangent in?
Quadrant 2 and quadrant 4.
Perfect. Just like the one above it, just like number 4. Number 4, we had a negative value for tangent, so we're in 2 or 4. Number 8, we have a negative.
120. Oh.
Good. Yep. Thank you. 120 and
120 and 300.
perfect, and 300. All right. Let's go ahead and do some of these problems in radians. And really, radians is all you'll see in AP Calculus. But do we have any questions on these 4 before we move on? All right. Let me let's make this travel with us. Okay. Okay, and now, let me see if I'm able to erase this. Nope. So now 30 degrees, we're no longer thinking 30 degrees, we're thinking pi over 6 radians, 180 divided by 6. We're no longer thinking of this as 45 degrees, we're thinking of this as pi over 4. And this is pi over 3. All right, but it's the same thought process. Sine of some angle is negative 1/2. So I'm looking in the chart for sine to have a value of 1/2, positive or negative, and it's pi over 6 radians. So my reference angle is pi over 6 radians. And same thought process, what two quadrants can I have a negative sine value in? Well, in the bottom. Sine is based on the y-coordinate. Y is negative in the bottom half of the graph. Third quadrant and fourth quadrant. I don't know if it's because I'm recording, but my thing's having speed issues. All right, so I'm going to make a little sketch. I can be pi over 6 below the x-axis in the third quadrant, or pi over 6 radians below the x-axis in the fourth quadrant. If I was in degrees, I would be thinking of this on the left as 180, but it's pi radians, and I'm thinking in sixths. So I'm thinking to myself, 6 pi over 6. And over here on the right side, the equivalent of 360 degrees is 2 pi, 12 pi over 6. So how about anybody? What's my third quadrant answer going to look like?
7 pi over 6.
Good, 7 pi over 6. After 6 pi over 6, I'm 1 pi over 6. After 6 pi over 6, so that makes it 7 pi over 6 radians. And how about my fourth quadrant answer?
11 pi over 6.
Good, 11 pi over 6. Okay. All right, let's do a couple more and then have you guys try some, and then we'll kind of finish up on rational functions today. We'll throw in the last piece. All right, number 10. Cosine has a value of root 3 over 2. I'm looking in the chart, in the cosine row, pi over 6 again. Here's a second one in a row where my reference angle is pi over 6. Thomas, what quadrants can cosine be positive in?
One and two.
Yes on 1, but look at quadrant 2. 2, you're looking at the S.
Oh, no, yeah. 1 and 4.
Good. Quadrant 1 and 4. Nice. All right. So 1 and 4. So we'll make a sketch. Now I've lost the lag, so I can write normally again. Pi over 6 above the x-axis in quadrant 1, or pi over 6 radians below the x-axis in quadrant 2. In quadrant 1, don't forget your reference angle is the angle. 0 plus pi over 6 radians is just pi over 6 radians. Anybody, how am I thinking of 2 pi? Well, I'm thinking of it at, right,
12 pi over 6.
12 pi over 6, same as the last problem. So again, same answer for my fourth quadrant answer as the last problem, because it's the same reference angle. All right, this one was just pi over 6 in quadrant 1 and 4, whereas number 9 was pi over 6 in 3 and 4. So pi over 6 radians and 11 pi over 6 radians. All right, let's do number 14 and then have you guys try some. So number 14, sine has a value of negative root 2 over 2. So I know my reference angle in radians is pi over 4. And I've got a negative value for sine. So Brian, what 2 quadrants could I be in?
The third one and fourth one.
Nice. Did you say third and fourth?
Mm-hmm.
Good. Yep, third and fourth. Same as number 9. I've got a negative value for sine, so I've got to be in the bottom half of the graph. Same situation in number 14. So I'm going to make a similar sketch to number 9, except my reference angle is pi over 4 this time. And this is 1 pi, but in fourths, it's 4/4 pi. And over here is 8/4 pi, or 2 pi. Brian, you think you can handle the final answers? Or you want me to pick on somebody else?
5 pi over 4.
Good. 5 pi over 4. Because I'm after 4 pi over 4. And how about this fourth quadrant answer?
7 pi over 4.
Good. I'm before 8 pi over 4. So my answer is 7 pi over 4. All right. Anybody need to look at that for another minute or have a question? Okay. Have you guys try 4 and then we'll switch topics. Switch gears. So I've decided that what we're going to do is this weekend's homework will be a practice test. All right. And instead of giving you a test on Monday, I want you to really put some good effort into it this weekend and come to class Monday with questions. Anything that you realize you don't understand well, make sure you come to class Monday with questions. We'll go over the whole practice test, and then we'll have a little live test Tuesday morning before we move on to some more material. All right, but why don't we take 5 minutes, try these 4 problems, try to answer in radians, give me all solutions between 0 and 2 pi, which I didn't really highlight the instructions there. It says give all solutions between 0 and 2 pi radians. So it's the equivalent of asking for answers between 0 and 360 in degrees. All right, so let's go 5 minutes on this. right, let's start checking in on these. Ramon, what two quadrants can we be in number 11?
Number 11, I said the first one and the third one.
Good. The first one and the third one. So pi over 6 up here, pi over 6 down here. What did you get for your first quadrant answer?
7. Oh, for the first one, it's pi over 6, and then for the third one, I said 7 pi over 6.
Perfect, because we're thinking of pi as 6 pi over 6. So that means this is after it, it's 7 pi over 6. Let's see. Victoria, what'd you get for your two quadrants in number 12? Where can cosine be negative?
So for the second quadrant, I got 3 pi over 3.
Okay, second quadrant is 1. What's the other quadrant?
Then for the other quadrant, I got 4 pi over 3.
Okay, so third quadrant. You're in the right quadrant. So your two quadrants are 2 and 3.
Mm-hmm.
And this is 3 pi over 3. It sounded like you said 3 pi over 3.
Oh, 2 pi over 3.
Good, 2 pi over 3, and you're correct on this one, 4 pi over 3. Because we're pi over 3 before 3 pi over 3, and then pi over 3 after.
Okay.
Nice job. All right. How about on? What two quadrants can we be in number 15? 2 and 3. And what are our two answers?
3 pi over 4 and 5 pi over 4.
Good. 3 pi over 4 is my third quadrant answer. 5 pi over 4 is my third quadrant answer. I'm speeding up just because I'm thinking of how much I want still to cover today. But if I'm going too fast, let me know. Anybody am I going too fast for? All right. Then this one here, you're in quadrant 1 or quadrant 3. Pi over 4 is your reference angle. So in quadrant 1, that means pi over 4 is my answer. I'm thinking of this as 4 pi over 4. So that means my third quadrant answer is 4 pi over 4 plus 1 pi over 4, which means it's 5 pi over 4. Any last minute questions on this stuff? All right, so here's where it gets a little interesting. We're going to look at some notation for, we're kind of familiar with the notation, but we're going to be looking at how to describe behavior, end behavior of rational functions, and behavior near discontinuities. All right, and these are not actual, these are like hand drawn, but they're based on actual rational functions. They're just, everything's kind of exaggerated to give us a feel for this notation. All right, and there's a lot going on here today. This is one of those things that some people get this in like the first 5 minutes, and it's just easy, and then some people it takes a while. So we'll do our best to keep you on board. When you first start AP Calculus, you're going to be talking about limits, most likely. But just about every calc teacher that I'm aware of in the city starts off with limits. And understanding what we're doing here today will drastically increase your understanding of what you're talking about with limits. So I've got 8 questions here, and they kind of go in order from left to right. On these questions, I'm going to start off with a question about the left end of the graph, and I'm going to finish with a question about the right end of the graph. So question A starts off with, as x approaches negative infinity, anytime you see somebody asking about what's going on as x approaches negative infinity, they're talking about the left end of the graph. They're talking about the left end. And anybody can answer this. What's the left end of this graph doing? Is it shooting to positive infinity, shooting to negative infinity, or leveling off?
Negative infinity.
Okay, well, negative infinity means it's like this arrow here. This is going to negative infinity. A graph that's going to negative infinity would just shoot down eventually on the left.
Positive infinity.
Okay, positive infinity
Does it just level off?
means it would be shooting up. It is leveling off. Can you see the red arrow there that I drew?
Yeah.
It's leveling off at what y value? What's it seem to be getting closer and closer to? Y equals what?
Negative 7.
Okay. So whoever said negative 7, negative 7 is supposed to represent this x value here. This arrow here, this graph is getting closer and closer and closer to the x-axis. All right. So it's approaching a y value of 0. All right, this is going to take a little while, but we'll do what we need to get you guys the hang of this. Now I'm going to answer the last question, question H. Question H is anytime we ask about x going to positive infinity, we're looking at the right-hand end of the graph. And as you look at the right-hand end of this graph, what's it doing? Is it getting higher and higher, lower and lower, or leveling off?
Leveling off.
Leveling off. And what y value is it leveling off at?
X equals 0.
Y equals 0. I'm getting closer to the x-axis, so x is getting bigger and bigger and bigger, but y is approaching 0. All right, and really, if you look at this graph, it's really hard to tell if this graph is getting any lower at all, but judging based on what we know about rational functions, they either shoot to positive or negative infinity on the end, or they level off at 0 or a fixed value. And judging from this graph, it seems like they're getting closer and closer to the x-axis. All right. So the rest of these questions are asking about behavior near discontinuities. I have 3 discontinuities in this graph. 3 places where I'd have to pick up my pencil if I was trying to trace this whole graph. I've got a hole at x equals negative 8, and I've got vertical asymptotes at x equals negative 7 and x equals 9. All right. Questions B and C are asking about what's going on near negative 8. All right. And I'm guessing you haven't seen this notation before. If you have, then you're ahead of the game. But do you see how there's a negative in front of the 8 and there's a little negative after the 8 that's superscripted, that's higher?
Yeah.
The way we want to read this, what we think to ourselves is as x approaches or gets closer to negative 8 from the left, from the negative side. And this one here is asking me as x gets closer to negative 8 from the right side, from the positive side. All right, and I'm going to do my best to try to highlight this on the graph here. So question B is asking, what happens as I read the graph like this? As I'm getting closer and closer to negative 8 from the left. I'm coming from this direction. As you read this little red arrow, what's y getting closer to?
-7.
Good. Y is getting closer to -7. All right. And now.
Wait. I think I disagree.
Thank you. It is not -7. Thank you, Mr. Kaplan. 2 points again. You're the best. It's not negative. Yeah. So whoever said -7, go back and look at this one more time. You want to look at the y value. Look at it. Follow it over here. What's the y value that we're getting closer to?
1.
+1. Whoever said -7, are you seeing that now?
I don't understand though.
Okay. If you had to read the coordinates of this hole, what would it be? -8, comma what?
Is it 1?
Yes. All right. So, and that's the idea. This is what number or letter B and letter C are asking about. They're asking, what's happening as I read this graph, getting closer and closer to that hole from both sides. As I read the graph, if you follow this red arrow here, aren't I getting closer and closer to -8 from the left? X is getting closer and closer to -8, and Y is getting closer and closer to 1. That's what this is saying. And now question C is asking me, what happens as I approach -8 from the right-hand side? So I'm reading this graph. I'm getting closer and closer to -8 from the right-hand side. And aren't I still squeezing in on that same point, -8, comma 1, from both sides? So from both sides, y is approaching a value of +1. All right. Answer B is saying, as I get closer and closer to that x value from the left, I'm getting closer and closer to a y value of 1. Question C is saying, as I get closer to -8, an x value of -8 from the right, y is getting closer and closer to 1. In other words, I'm squeezing in on that point, -8, comma 1, from both sides. All right, here's a picture of what it would look like if I wasn't approaching the same point from both sides. If I had a graph that looked like this, if I had a hole at -8, and then on the other side, it picked up and went like this, right? This left-hand piece would be approaching a lower y value, and this right-hand piece would be approaching a higher y value. But that won't happen with a regular rational function. All right, we're going to do a few examples of this before I ask you to try some on your own. So let's I do want the questions, but I'm just saying don't panic. If it seems like I'm going a little fast, I'm going to make sure we do a couple of these. All right, now, question D. I'm asking about what's happening near -7. And if I look at this graph, I've got a vertical asymptote. The graph shoots up on one side and down on the other side. All right, so I'm looking at what happens as I get closer to -7 from the left. What's this graph doing on the left side of x equals -7? Is it shooting up to the sky or shooting down to the floor?
Shooting up.
Okay. On the left side, all right, here the dotted line is the vertical asymptote. If I'm on the left side, I'm looking at this arrow. As I read this arrow, I'm getting slowly closer to -7 for x, but I'm shooting up higher and higher into the sky. I'm approaching positive infinity. All right, now question E is asking, what's happening on the right side of -7? As I get closer to -7 from the right side, well, I'm reading this arrow. Here I'm on the right side of the dotted line, but as I get closer and closer to the dotted line, y is getting lower and lower, so y is approaching negative infinity. All right, and based on like experience, I'm guessing probably like 40% of you understand enough to tell me F and G, and 60% of you still confused. But does anybody think they have the answer for F and G? What would they be? What would the answer to F be?
Negative infinity.
Negative infinity, good. And what would the answer to G be?
Positive infinity.
Positive infinity, good. So I want you to, if you didn't understand those answers, let me do my best job of trying to make sure you do. If you look at the first vertical asymptote, the first dotted line, you can see here on the left side I'm shooting up, on the right side the graph shoots down. Well, for the vertical asymptote at x equals 9, it's the reverse. I'm going down before the vertical asymptote and up after it. So this arrow is getting closer and closer to positive 9 from the left side, but y is getting lower and lower, so it's going to negative infinity. If I read this arrow, I'm getting closer and closer to positive 9 from the right side, but y is getting higher and higher. It's going to positive infinity. All right, one example is not going to be enough. Let's do another one. Okay, actually, yeah. Okay, example 2. Opening board. Can people see this okay?
Yes.
Yeah.
All right, excellent. So we've got a lot of action here. We've got a horizontal asymptote again. We've got 2 vertical asymptotes and a hole again. So let's start off with the left end and the right end. Question A is going to be asking about the left end in all of these, and the last question is going to be asking about the right end. So this here is asking me about the left end of the graph. When I follow this left end of the graph, is it getting higher and higher and higher, lower without stopping, or is it leveling off at a particular y value?
Leveling off.
Good, it is leveling off. And what y value is it leveling off at?
At 2.5.
Good, it's getting good. It's getting closer and closer to this dotted line, which, as you can see from the graph, is y equals 2.5. All right. And anytime, remember, anytime you have a horizontal asymptote, both ends are leveling off at the same value. This end is also leveling off, getting closer and closer to that dotted line. So the right end, y is also getting closer and closer to 2.5. When we say y approaches 2.5, it gets as close as you can imagine to it. It just won't ever touch it. All right. So now let's look at question B and C. When I look at question B and C, I'm concerned with what's going on either side of -4. And what kind of discontinuity do we have at -4? A hole or a vertical asymptote?
A hole.
A hole.
A hole. So we can expect we're squeezing in on the same y value from both sides. Question B is asking me about when I get closer and closer to that hole from the left side, what y value am I getting closer and closer to?
3.
3, good. If I had to read the coordinates of that hole, they would be -4, 3. So as x approaches -4 from the left is how I read this, y approaches 3. And question C, the way to read that is as x approaches -4 from the right, and this is what I'm looking at on the graph, y is approaching that same y value. Y is approaching 3 from both sides. Is this feeling a little bit better on the second example? Or no?
Yeah, it is for me.
Yeah.
Okay. All right, now let's take the next pair of questions. They're also related. These two questions are concerned about what's going on either side of x equals -3. What kind of discontinuity do I have at -3? A whole or a vertical asymptote?
Vertical asymptote.
Vertical asymptote.
Good, a vertical asymptote. So what happens at vertical asymptotes, your graph either shoots to infinity or -infinity on either side of the graph. What's going on the left side of -3? Am I going to positive infinity or negative infinity?
Negative
Positive.
infinity.
Okay. There's always somebody who's not sure. Here's my vertical asymptote, right? Here are my two arrows. This one, the up one, and the down one. Which one's on the left side of the dotted line? The up arrow or the down arrow?
The up arrow.
The up arrow. So this one right here, this one is on the left side of the dotted line. As I read this arrow, I'm getting closer to the dotted line from the left. And y is going up and up and up. Y is approaching positive infinity. All right. And then this other arrow, this one down here, this is on the right side of the dotted line. But as I read it this way, I'm getting closer and closer to the dotted line from the right. And this arrow keeps going down and down and down. So that means y is approaching -infinity. All right. F and G, they're asking about what's going on near +3 on either side of x equals +3. And I've got another vertical asymptote. This question is asking what's happening on the left side. Which arrow is on the left side of +3? The down arrow or the up arrow?
The down arrow.
The down arrow. This arrow, as I read it this way, I'm getting closer and closer to +3 for x, but I'm getting lower and lower and lower for y. So I'm approaching -infinity. And then this arrow, I'm getting closer and closer to +3 for x, but from the right side. I'm on the right side of 3. And y is getting higher and higher and higher, so it's approaching +infinity. All right? And so just, this left arrow leveling off at 2.5. Both sides of the hole, I'm approaching a y value of 3. Then for my asymptote, I'm up on the left, down on the right. So +infinity, -infinity. Then my second asymptote, I'm down on the left, up on the right. So -infinity for F, +infinity for G. And then the right-hand arrow is leveling off at 2.5. All right, let's do one more together, then I'm going to break you out into the whiteboard FI rooms. We'll do some breakout rooms and try one or two on your own. All right, one more. Example 3. Okay, this one's a little quicker, but just so we've covered all the bases. All right, on the left-hand side, let's start with as x goes to -infinity. What are we doing? Is y going higher and higher, lower and lower, or leveling off?
Going lower.
Going lower and lower. So I want to say -infinity on the left-hand side. Y is approaching -infinity on the left. And now let's answer question H. How about somebody else this time? Because I'm pretty confident Ramon's got this stuff. What should I answer for question H? What's y doing?
Positive infinity.
Good, positive infinity. It's getting higher and higher and higher. There's no horizontal asymptote on this one. We're just shooting off to -infinity on the left and positive infinity on the right. All right. Now, questions B and C are asking about what's happening on either side of 0. The left side of 0 and the right side of 0. What kind of discontinuity do we have at x equals 0? a vertical asymptote, or a hole?
Asymptote.
Good, a vertical asymptote. And so, Mata, if you look at the y-axis, this is a vertical asymptote here for this graph. What do I do? Am I up on the left and down on the right? Or am I down on the left and up on the right? Which arrow is on the left-hand side? The up arrow or the down arrow?
Up arrow.
What do you say, Mata? You still with us, Mata? Oh, maybe he's not here. Yes, you were correct. Was it Diana that said up arrow? I'm starting to recognize people's voices, but if I'm not quick, I don't see who's talking. But yes, this up arrow is on the left. So I'm shooting to positive infinity on the left side of x equals 0. This down arrow is on the right side of x equals 0. I'm getting closer to the asymptote from the right side, negative infinity on the right. All right, Nicoletta, what are you still with us?
Yeah, I'm here.
All right. Do you think you have an answer for D and E, or not sure what to do?
I'm not sure.
Okay. Well, let me ask you this. They're both asking about what's going on near positive 2. D is asking what's going on as I get closer to 2 from the left. E is asking what happens as I get closer to 2 from the right. What kind of discontinuity do I have at x equals 2? An asymptote or a hole?
A hole.
A hole. All right. And what would the coordinates of this hole be if you had to read them?
2, 1.5.
Good. So on a hole, just remember, no matter which side we're coming from, as I squeeze in on the hole from this side, or as I squeeze in on the hole from this side, I'm approaching the same y value from both sides. All right, so I'm approaching a y value of 1.5 from this side, and I'm approaching a y value of 1.5 from this side. All right, this first arrow, this one here, gives me my answer to D. I'm approaching 1.5. This second arrow, this one here, gives me the answer for E. But they're both squeezing in on the same y value. All right, so here's what I'm going to do. I'm going to break you up into some breakout rooms. I'm going to put one of these, and I'm going to force one of these pictures on your whiteboard. So don't clear it, just write on it. All right, so I'll put a picture just like this on your whiteboard, and you just go ahead and write answers like that on it. Okay, and even if you're not sure, if you would take a guess, I don't really have a feel for what your thought process if you have a blank whiteboard. So if you would try to put something on there, I guess worst case scenario, if you just put like no clue, but just so I can tell whether you're still thinking about it or you're just lost. All right, but if you have a guess, put something down. That'll give me a feel for how well I did explaining this stuff today. All right, but a rule of thumb that I have as a teacher is if you're paying attention and you're not understanding it, I consider that my fault. If you're not paying attention and you're not getting it, that's your fault. But if you're trying and you're not getting it, I'm doing something wrong. Or I'm not trying enough. All right, so let's do some breakout rooms here. Okay, Mr. Kaplan, you guys in breakout room 2, we'll have Mr. Kaplan again, and I'll join breakout room 1. But before we do this, actually, we're gonna go to whiteboard.fi, and I'll be able to see everybody's no matter which room you're in. And okay, hold on a second. Okay. The code will be M, and I'll put this in the chat. M6V73. Figure this stuff out here. So if you're already on the website, just put in the last digits of this code that I just pasted in the whiteboard, or you can click on the link. But it's M6V73. All right, I'm going to open up all the rooms. I'll post the picture on your whiteboard, and you look at it and try to give me the answers. All right, and then I will put after a few minutes, I'll put the correct answers on, and we'll do another one. All right. Okay, let me join the breakout room. Okay. Okay. Put this down here. Okay. Just getting my act together here. Cancel my whiteboard. Okay. Insert an image. Number 1. Actions. Can you guys see that? Is it big enough for you to work with?
I just can't see the plus and the minus on the number.
Oh, okay. So the minus is always before the plus. So B is approaching -2 from the left, and C is approaching -2 from the right.
All right, thank you.
Can you send a link to the whiteboard?
Yeah.
Yeah, I did put it in the chat. Let me. Can you open up your chat and see it, or do you want me to send it again, or you want me to
Can
just
you send it again, please?
send it again?
Yes, please.
Okay, it's let me know if you see it. Oh, you know what? Do you see it now?
Yeah, you sent it, but it's not a link. Like if we can't just click it like we normally do.
Oh, okay. So try just going to try it like this. Go to whiteboard.fi. It should be a link, and use code M6V73. And I do know how to spell 2. I just hit an extra O in there. Let's see.
drawing an infinity sign on this is so weird.
You can just write the answer on the little line, Ramon, if you want.
All right.
Yeah, you don't have to copy.
Yeah, that's better.
Yeah, you don't have to copy the questions. Jocelyn, are you still having trouble? Jocelyn? Okay, I'm going to show you guys the answer. Brian, are you in this room now?
Yeah.
I noticed you didn't have anything. Or were you having trouble getting onto the site? That's why I moved you into my room. I couldn't talk to you.
I was doing it on paper.
Oh, okay. On the next one, just try to write your answers right on the whiteboard if you're able to.
Okay.
Okay. No, I'm sorry. 2, yes. All right, I'm going to push my answers to you. Most of you guys did a nice job. All right. Okay.
Mister,
Yes.
You're gonna put today's class. You're gonna post this on your YouTube channel.
The stuff that was on whiteboard, I can't. I'm not
No,
able.
just to the class.
Yeah, everything up until we got to the whiteboard. Yes.
Okay, thank you.
Okay, sure.
I think I'm gonna need to watch it a couple of times.
Okay.
And keep.
All right. Yeah. No, I'll do that right after class. Hold on 1 second. Okay. Jocelyn, can you hear me? All right, Elizabeth. You'll notice the left and the right ends are leveling off on the, getting closer and closer to the x-axis. So you want to say y is getting closer to 0. All right, Ramon, you got this down.
I did.
Yeah.
I was second guessing myself.
Yeah, no, you nailed it. And Diana, you too. Nice job. And Elizabeth, the 0.8, that's the y value of the hole, right? But the hole's at 1, 0.8. So you want those answers, the 0.8, you want to put 0.8 on the questions that ask about what's going on at positive 1. All right, at negative 3, you've got a vertical asymptote. So for the vertical asymptotes, you want to give answers of positive or negative infinity. Here, let's see. All right, you better, Elizabeth. But aren't you shooting up on both sides of the first vertical asymptote?
I don't know what you're talking about.
Yeah. So if you look at the graph, the first vertical asymptote, right, at x equals negative 3.
Okay.
Aren't both arrows on either side of that dotted line? They're going up.
Okay.
So you want to answer positive infinity for both sides as x approaches negative 3. If you look at the other vertical asymptote, you'll see it goes up on one side and down on the other. Nice, Ramon.
Yeah, I'm trying to remember the whole unit circle. I can only remember this the first quadrant.
Yeah, well, really, that's all you need. If you can figure out the first quadrant, you can use symmetry to figure out the other ones.
That is true.
All right, Elizabeth, looking better. All right. Just so I don't run class too late, I'm usually trying to get you guys out of here before 10. Let me Let me write the answers on here, push the answers to you guys, and we'll okay, so this one's 0. What am I doing? 0, positive infinity, 0.8, 0.8, positive infinity, negative infinity, 0. And let me push this to everybody. Okay, let's close these breakout rooms. Ramon, you got some artist in you there, I see. Sorry guys, I did it again. I left the room somehow. If anybody wants to stick around for questions, please do. Otherwise, have a great weekend. I'm going to put the practice quiz on Google Classroom. If you want to talk about this particular problem, let me know.
All right. Bye-bye.
Bye-bye.
I'll see you on Monday.
Yeah, have a great weekend.
Or on Friday if I see you there.
Oh, yeah, excellent. Yeah, I'll probably see you tomorrow.
All right. Bye-bye.
Okay.
Thank you.
See ya. Elizabeth, you look you look irritated by that problem. Would you like to look at it together? Yes?
Yes.
Okay, all right, let's do it. Let's see. Interesting. Okay, hold on. I'm going to share open board with you. Cancel.
I can't stay. I have questions, but I have to go. I mean, you probably can see that I have questions from my work, but I have to go.
All right. So actually, you're. Oh, never mind. I was going to say your answers are good, but those are my answers. All right. So tell you what, Chelsea, do your best on the practice quiz. Come to class Monday with any questions you have, and I won't really have. I'll have a backup plan if we can go on, but I'll dedicate all Monday to just making sure you understand the practice test. So any questions you have, don't let me off the hook until I've explained them to your satisfaction. Okay.
I'll probably watch a couple YouTube videos, and I don't think it's you. I'm just really tired today.
Yeah. Well,
I did not get any sleep last night trying to work on that homework.
Yeah, no problem. But yeah, this is all normal. It's confusing stuff at first. Some people get it right away, and some people it takes a while. But once you get it, you'll think it's the easiest thing in the world.
Okay, thank you.
All right,
Thank you so much.
Have a great
everyone.
weekend.
Bye, Elizabeth.
Bye. All right, Elizabeth. So let's take a look at number 2. Okay. Documents. All right, so this is the one that we were looking at on the whiteboard, right? Okay, so the left and the right end. I kind of told you it's 0, but I want to make sure you understand that it's 0 on your own terms. So first of all, the left arrow on the graph. We're always looking at the left arrow if we're saying x is going to negative infinity. And what's that arrow doing? Getting higher and higher, lower and lower, or just leveling off?
It's leveling off.
Right. And anytime it's just leveling off, you know, if the graph didn't make it obvious that it's a value, it's probably leveling off on the x-axis. So what's the y value if I'm on the x-axis? Like if I'm, 0, right? I'm getting close, like this point here, this red point's really close to 0. This one's really close to 0. In theory, I'm getting closer and closer to 0. So on the left end, I'm getting closer to 0. On the right end, same thing. In fact, it looks like it's touching the x-axis, doesn't it, on this right arrow?
Yes.
So I'm getting closer and closer to 0. Do you think we have the idea on the A and H? If you're not 100% sure, let me know, and I'll try to do a better job.
Okay, I got it now.
All right. All right, so now let's look at B. I'm being asked about what's happening on either side of x equals negative 3. So I look at my graph and I'm asking myself, what's going on at negative 3? What kind of issue do I have at x equals negative 3? An asymptote or a hole?
Asymptote.
Asymptote, right. And so now you want to ask yourself, find the two arrows that are squeezing in on the dotted line and ask yourself, are they going up or down? What's the one on the left side doing?
Going up.
Going up. So that's this one. And what's the one on the right side doing?
Also going up.
Also going up. So I want to answer positive infinity on the left side of the asymptote, and I'm approaching positive infinity on the right side of the asymptote. All right, now let's look at the next pair of questions. The x value is positive 1, and D is asking about positive 1 on the left side. E is asking about positive 1 a little bit to the right side. What happens as I get closer to 1 from the right side? D is asking what happens as I get closer from the left side. What kind of issue do I have at positive 1? An asymptote or a hole?
A hole.
A hole. So I'm squeezing in on a particular point. What's the y value of that hole that I'm getting closer and closer to?
0.8.
0.8. So 0.8 from the left side. And I'm squeezing in on that same point from the right side. So 0.8 again.
Okay.
All right.
Mm-hmm.
All right. Now let's think about these last two. Well, F and G. What's going on at x equals positive 3? A vertical asymptote or a hole?
A vertical asymptote.
Right. So I know my graph is going to ride that asymptote. It's going to shoot straight up into the sky or lower and lower and lower. What's it doing on the left side of that vertical asymptote? Up or down? Up. Good. I'm going higher and higher and higher on the left side. So y is approaching positive infinity on the left side of positive 3. And what's it doing on the right side of that vertical asymptote?
Going down.
Right. It's shooting down on the right side. So y is approaching negative infinity.
Can you just take a picture of this?
Yeah. If you have time, I can give you one more for you to try on your own.
Okay, let me do that.
All right. Tell me when you're ready.
I'm ready.
Okay. Hold on one second. Mr. Kaplan's calling me. Hi, Mr. Kaplan. How you doing? Yeah, I'm just have Elizabeth here. I somehow managed to screw up leaving the breakout rooms. I think I ended the Zoom call, and when I got back. Okay. Thanks. Bye bye. All right. Yeah, I think I cut off half the class. When I got back, there was only the people from our breakout room. Okay, number 3. All right. So why don't you try this one, Elizabeth? And let me know when you want to check an answer. You can check them one by one, or you can do the whole thing, and then let me know. Let me know when you're ready to check in with me. All right? Can you still see the graph, Elizabeth?
No.
Oh, so you can see my whiteboard screen?
Yes.
Okay. Let me put the graph back. Sorry about that. Okay.